All right, let's talk about C#. We've got this amazing toolbox full of powerful keywords, right? But there are three in particular, var, dynamic, and object, that seem to cause a lot of confusion. Today, we're going to open up that toolbox, lay them out side by side, and figure out what each one really does and when you should be reaching for it.
On the surface, they all kind of look like they offer flexibility, but underneath the hood, they work in totally different ways. And honestly, picking the wrong one can lead to code that's fragile, super slow, or just a nightmare to read. So let's dive in and break down the real difference so you can be confident you're always choosing the right tool for the job.
Okay, first up is var. I want you to think of var as your go-to, everyday tool. It's the one you'll probably use the most, and its whole purpose is to make your code cleaner and just easier to read, all while keeping the safety checks right where they belong, at compile time.
Now, the most important thing to get right off the bat is this. var is not a new type. It's not some kind of variant that can change its mind later. It's what we call syntactic sugar. You're basically just telling the compiler, hey, you're smart, look at what I'm assigning on the right, and you figure out the type for me. And once the compiler does that, boom, that type is locked in, just as if you typed it all out yourself.
And here is where you really feel the difference. Just look at this. On the left, we're saying the same thing twice. It's long, it's repetitive, it's just noisy. But on the right, var cleans it all up in one move. The code is instantly easier to scan, and the best part, you haven't lost a single ounce of that all-important type safety. So var is an absolute rock star with things like link queries or anonymous types. Situations where you literally can't even write out the type name. But it's not a free-for-all. There are a couple of ground rules. First, you have to give it a value right away so the compiler knows what to do. And that means, second, you can't just assign null to it without any context. This quote just nails it. The golden rule for var is all about clarity for the human reading the code. If the type is super obvious from the right-hand side, like new customer, then var is your best friend. But if the type is a bit of a mystery, say from a method call like getSettings, do yourself and your team a favor and just spell out the type. All right, let's grab the next tool from our box, object. Now, this isn't just another keyword. Object is, it's the granddaddy of them all. It's the base, the ancestor of every single type in the entire .NET ecosystem. Think of it as the ultimate one-size-fits-all storage container. And because absolutely everything in .NET, from a tiny little integer to a massive complex class, ultimately comes from object, a variable declared as object can hold, literally anything. This gives you some incredible power to do things like build APIs or collections that need to handle a mix of different data types. But, and this is a big but, all that flexibility comes with a hidden cost. When you take something simple, like an integer, and put it into an object, the system has to perform a little dance called boxing. It wraps that value up in an object wrapper and moves it over to the heap. Then, to get your number back, you have to explicitly unbox it. All of that wrapping and unwrapping takes extra CPU cycles and memory. So you see the trade-off, right? On one hand, you've got this awesome power to store anything. But on the other hand, the compiler can't help you anymore. The responsibility for type safety is now completely on your shoulders. You have to cast it back to the right type, and if you get it wrong, your program doesn't just give you a bad value, it throws an invalid cast exception and comes to a screeching halt, all while paying that performance penalty. Okay, and now for the real power tool. The one that came along in C# 4.0 and completely changed the rules of the game, dynamic. This keyword basically tells the compiler to just step aside and let the runtime figure things out later. What this means is that the compiler completely trusts you. When it sees the dynamic keyword, it essentially throws its hands up and says, okay, I'm not even going to look at what you're doing with this. I'll just assume it's all valid. All the checks for methods, properties, you name it, they all get kicked down the road until the code is actually running. It's powerful, for sure, but as you can probably guess, it can be a little dangerous. So at compile time, the compiler sees this line and it just nods and says, yep, looks good to me. It doesn't question it. It doesn't check anything else you do with that user variable. It just trusts that you know exactly what you're doing and gives you a big green check mark. But then you actually run the code. And that's when the runtime wakes up, looks at your user variable, sees it's actually an integer, and realizes, wait a minute, integers don't have a length property. And that's when your application crashes with a runtime binder exception. The safety net that the compiler usually provides is just gone. So you might be wondering, with all that risk, why on earth would we ever use this? Well, it's absolutely essential when you're dealing with the messy, unpredictable outside world. Things like data from a JSON API or interacting with dynamic languages like Python. It makes that kind of code so much cleaner. But the trade-off is huge. You lose that compile time safety, and maybe even worse for day-to-day coding, you lose IntelliSense, that helpful autocomplete you rely on. Poof, gone.
And let's talk about performance. This chart shows it all. Look at this. A dynamic call is more than 10 times slower than a normal direct call. Now, to be fair, it's way, way faster than old school reflection, but that's still a pretty significant performance hit that you absolutely have to be aware of before you start using dynamic everywhere.
Okay, it's time for the main event. Let's put these three tools side by side in a head-to-head showdown and see how they stack up on the features that matter most. This table really tells the whole story. And if you look closely, it all comes down to that very first row: type, resolution. var and object are figured out at compile time. Dynamic is figured out at runtime. That one single difference is what causes all the other dominoes to fall. It's why var is super safe and fast. It's why object needs you to do the casting and has that boxing overhead. And it's why dynamic gives up safety for flexibility and takes that performance hit. It all starts there.
So, with all that in mind, how do you actually decide which tool to pull from the toolbox on any given day? Let's put together a simple playbook to make that choice crystal clear.
Here's the game plan, and it's pretty straightforward. For, say, 95% of your daily coding, when you know the type you're working with, you're going to reach for var. It gives you the best of all worlds: readability, safety, and performance. You'll save object for those specific, rare cases where you truly need a universal container. And you'll keep the dynamic power tool reserved for its special job, talking to that unpredictable, dynamic world outside of your clean .NET code. So you see, mastering these keywords isn't really about memorizing a bunch of rules. It's about understanding that fundamental trade-off between compile time safety and runtime flexibility. Every time you declare a variable, you're making a choice along that spectrum. So the real question isn't just what are you going to build next, it's how intentionally, how thoughtfully are you going to build